Can you see the screen now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes.
Oh, yes. Okay. Limit supremum and limit infimum. Today we are going to discuss limit supremum and limit infimum. Wait 1 second. Okay, so for this we will consider a bounded sequence. Consider a bounded sequence. Bounded sequence N, and let us define, let Tk or let Tn, we will define now Tn. Tn is equal to infimum of n, n plus 1, n plus 2 and so on. That is, infimum is taken over k greater than equal to n ak. And we define capital Tn as supremum. Supremum of n, n plus 1, n plus 2 and so on. We can write this as supremum taken over k greater than equal to n k k. Can you see whatever I have defined Tn and small tn and capital Tn?
Yes, ma'am.
Okay. So we have considered a bounded sequence. Sequence n is a sequence of bounded real or sequence of real numbers, which is bounded sequence. And now we are defining small tn and capital Tn. As what is small tn? I am defining infimum of n, n plus 1, n plus 2 and so on. And capital Tn I am defining as supremum of n, n plus 1, n plus 2. Well, actually this n, n plus 1, this is called as a tail of a sequence. Okay. This is known as a tail of a sequence n. Whatever sequence is there, consider its tail and take infimum of that tail and call it as small tn. And if you take its supremum of tail, call it as capital Tn. Okay. So what can you say about small tn? Whether it is an increasing sequence or decreasing sequence? Increasing sequence. Tn will be an increasing sequence. For example, let 1 by n we can take. Say my n is a bounded 1 by n is a bounded sequence. Is this a bounded sequence?
Yes, ma'am.
1 by n?
Yes, ma'am.
Yes, ma'am.
Bounded by? What is upper bound?
0.
1, ma'am.
1. Okay.
1.
Because this sequence is nothing but 1, 1 by 2, 1 by 3, 1 by 4 and so on. So nth term is 1 by n, 1 by n plus 1 and so on. Right? So I am taking infimum over So what is my small t1? T1. What will be T1 now for this sequence? Infimum of A1, A2. This is my A1, right?
Yes, ma'am.
Okay, let me denote my this. This one is my A1. This one is my A2, A3, A4. This is my AN and this is AN plus 1. Okay. So T1 is nothing but infimum of A1, A2, A3 and so on. So infimum of original sequence. T1 is nothing but infimum. Which pen I used? This one. 1 by 2, 1 by 3 and so on. What is T2? Small t2. It is infimum of
1 by 2, 1 by 3.
1 by 2, 1 by 3, 1 by 4 and so on. What is T3? Infimum of
1 by 3.
1 by
3,
3, 1 by 4, 1 by
1
5 and so on. So first few terms depending on T1, T2, T3 we have to eliminate and we have to consider its tail of a sequence. Okay. So Tn is nothing but 1 by n, 1 upon n plus 1 and so on. Small tn is nothing but infimum of 1 by n, 1 by n plus 1 and so on. Right. So what is infimum of this now? T1. T1 is nothing but infimum of this. So what is infimum of this sequence? Infimum means greatest lower bound. What is greatest lower bound?
1.
Lower bound.
0.
0, right?
0, ma'am. 0.
Yes. 0. What is T2? What is infimum or
0.
again
0.
0? Okay.
0.
Here also 0.
Again 0.
I am not getting.
Again 0.
Okay. Supremum, infimum, I will get the same here. I want to change it. I will take another example. Okay, first we will come to this only. Okay, 0 only. Now I will define capital Tn. This is increasing only actually. 1, 2, 3. Okay. Okay, now we have started with this example, so we will complete this first. Then I will take another example. Okay. So now what is capital T1? What is my Tn? Capital Tn now? Supremum. Supremum of
Supremum.
this 1, 1 by 2, 1 by 3 and so on. Right? So what is supremum of this?
1.
1.
1.
1.
1 by n.
Now, what is capital T2? Sorry. Supremum of 1 by 2, 1 by 3, 1 by 4 and so on. What is supremum here? Yeah, here it is changing, so no need to. 1 by 2, right? What is T3?
Supremum of 1 by 3.
Supremum of 1 by 3, 1 by 4 and so on. So supremum is 1 by 3.
1 by 3.
And T4, similarly I can write as T4 is 1 by 4, 1 by 5 and so on. So supremum is 1 by 4. So you understood what is, whatever I have defined small tn and capital Tn.
Yes, ma'am.
So what is capital
Yes,
Tn
ma'am.
then for here? Supremum 1 by n, 1 by n plus 1
1 by
and so on. So what will be here? 1 by n, right? So what can you say about here? I cannot say whether it is increasing or decreasing at present, for small t1. But can you see here about capital Tn, whether it is increasing or decreasing?
Decreasing.
It is increasing or decreasing?
Decreasing. Decreasing.
It is decreasing, like
Decreasing.
1, 1 by 2, 1 by 3, 1 by 4, 1 by n. So this capital Tn is a decreasing sequence, right? It is a decreasing sequence. And if we check another example, we will get this as increasing sequence. Okay, here we are getting same value, but okay, whatever we have defined here, infimum we are taking, in some elements we are removing, so it must be a increasing sequence, right?
Yes, ma'am.
So small tn is an increasing sequence. This is an increasing sequence, and capital Tn is a decreasing sequence. Is that okay?
Yes, ma'am. Yes.
For any bounded sequence, if we define small tn is equal to infimum taken over k greater than equal to n ak, then we will get it is an increasing sequence, and capital Tn is supremum of ak, supremum is taken over k greater than equal to n, then it will be a decreasing sequence. Okay. Now we define limsup and liminf with the help of the small tn and capital Tn. So if it is increasing sequence and it is bounded sequence also,
Yes, ma'am.
yes,
Yes, ma'am.
these are all bounded sequences, because whatever we are our original sequence is there, it is bounded sequence. So whatever small tn and capital Tn, they will be also bounded sequence.
Yes, ma'am.
So
Yes,
bounded
ma'am.
and increasing sequence. So small t1 clearly, small tn is an increasing and bounded sequence, as well as capital Tn is decreasing and bounded sequence. So if it is increasing and bounded sequence, so what can I say? Supremum exists.
Yes, ma'am.
Supremum exists. For this, supremum will exist, and for this, supremum exists, and this is decreasing and bounded sequence. So for this, I can have infimum, right? For this one, infimum exists, so I can define supremum and infimum for these two sequences. So we call it as limit Tn, therefore lim Tn is equal to, say, supremum of Tn, and limit capital Tn will be what? Infimum of capital Tn. Okay. So limit exists. Limit will be nothing but supremum of this, and for capital Tn, limit will be nothing but infimum of that sequence. Okay. Is that right?
Yes, ma'am.
Therefore,
Yes, ma'am.
I can define limit of Tn like this. Now define limit n tends to infinity, infimum of n is nothing but supremum of Tn, and that is nothing but supremum. Supremum is taken over n greater equal to 1, infimum k greater than equal to n a k. Is that okay?
Yes, ma'am.
And lim in, or I can write this as limsup. This is lim in and limsup. You don't if we don't write also, doesn't matter. I will write just lim in. Lim in of an is nothing but supremum of Tn, and that is nothing but this one. And limsup, what will be limsup? I can define as infimum of capital Tn. What is infimum of capital Tn? Infimum is taken over n greater than equal to 1, supremum taken over k greater than equal to n, capital, not capital, small ak. Is that okay? I can define like this.
Yes, ma'am.
Yes. So if it is n is a bounded sequence, I can define liminf of n as this one, supremum of small tn, where tn is nothing but infimum of ak, infimum of a 10, and limsup of a sequence is nothing but infimum of a 10. Okay. Infimum of tn is nothing but supremum of 10. Is that okay? This. And they will exist for because our sequence is bounded sequence. So liminf and limsup definition understood?
Yes, ma'am.
Yes. Now, if n is not bounded,
हॅलो मॅम.
yes,
मॅम या सिक्वेन्स साठी लिमिट इन्फिमम आणि सुप्रीमम मग एकच असतो का?
कुठे?
Zero?
which
म्हणजे लिमिट इन्फिमम एन इक्वल सुप्रीमम
हा आपण काढू ना. आता आपण काय केलं, फक्त T1 T2 Tn काढलं ना. 1/n साठी म्हणताय का तुम्ही?
हा हा मॅम.
1/n साठी ना. I have just defined. Okay, so we will write liminf also. So what is my liminf by definition? Liminf of 1/n, it will be supremum of small tn, right? Supremum of small tn. So what is this? Tn is nothing but my 0 only. T1, T2, T3 all are 0 only. So what is the supremum for that sequence? So what is liminf of 1/n? It should be 0 only. Are you there, students?
येस मॅम. येस मॅम.
Yes, ma'am.
So for that sequence, I am just writing over here. This for 1/n, liminf is 0 only. Supremum n greater equal to 1. Tn. Tn is nothing but this one. So T1, T2, T3, 0, 0, 0, 0. Okay. What is infimum of Tn now? Capital Tn. For this, what is my infimum of Tn? What is Tn? N greater equal to 1. T1, T2. Capital T1, T2. 1, 1/2, 1/3, 1/n, right?
मॅम ते पण 0 होईल.
Yes.
एका कंडिशनला 1/n साठी मग
1, 1/2, 1/3, and so on. So again we are getting 0 only, right? So for this sequence, liminf is equal to limsup. Is that right?
Yes, ma'am.
Limin for this, and that is nothing but limit. If limit exists now, limsup is equal to limin actually. Are you getting this? We know that limit n tends to infinity, 1 by n is what? It is 0 only, na?
0.
So
Yes.
limsup of 1 by n is nothing but liminf of 1 by n is nothing but limit of 1 by n. So if n is a convergent sequence, then limsup is equal to limin is equal to limit of a sequence. That theorem also we have to prove. Is that okay?
Yes, ma'am.
If that if whatever sequence is not convergent, then limin we will get different. Okay, we will consider that another example also. But first you see this definition only. Okay. Is that okay for this example? Liminf and limsup. Whether you understood limsup and limin. So simultaneously I have defined limsup and liminf, and for this example we have calculated also. Is that okay?
Yes, ma'am.
Ma'am.
Okay. Now we will take or first we will, if it is bounded, if it is not bounded, no, then let me take another example. Let example 2. Example 2. Let n is equal to minus 1 raised to n. Whether it is a convergent sequence?
No.
No, na?
No.
So 1 by n is a convergent sequence converging to 0. But now I am taking another example which is not convergent. So in that case, we will get limsup and limin. They are not equal. Okay, for this case we will get. So for this we will calculate T1, T2, T3 and so on. So what is T1? What is small t1 for this? By definition, what is my definition? Infimum of
In- in-
A1, A2, A3 and so on, right? Is that okay? Infimum of A1, A2 and so on. What is A1, A2 for this? What is A1? Minus 1, 1. Minus 1, 1. Minus 1, 1 and so on. So this is my A1, A2, A3, A4, A5 and so on. Okay. So what is infimum of A1, A2? Minus 1, 1, minus 1, 1 and so on. So what is infimum? Minus 1?
Minus 1.
Yeah. So T1 is minus 1. What is T2? Infimum of, so leave first term and 1 minus 1, 1 minus 1 and so on again. So again I am getting minus 1 only. T2. Are you getting this?
Yes,
Yes,
ma'am.
ma'am.
Are you getting this?
Yes,
Yes,
ma'am.
ma'am.
What is T3? T3 is again minus 1. So Tn is nothing but my minus 1 only. Is that okay?
Yes, ma'am.
What is capital T1? Supremum of A1, A2, A3 and so on. So minus 1, 1, minus 1, 1 and so on. So in any sequence, minus 1 and 1 will be there. So if it is supremum, we will get 1. So T1, T2 will be 1, right?
Yes, ma'am.
Are you getting this?
Yes, ma'am.
Yes, ma'am.
Yes.
So capital Tn is nothing but again 1. So what is limsup and limin? First we have defined liminf of n. For this case, what will be limin? It is supremum of small tn,
Tn.
right? And what is lim sup of an? For this example,
Capital T. Infimum of capital T.
lim sup of small tn, supremum of tn, supremum of tn. What is supremum of tn? -1, -1, -1, and so on. So it is -1, and this is infimum of capital Tn. But what is my Tn? Tn is a constant sequence.
One.
Infimum of a constant sequence, 1, 1, 1, and so on. So it is 1. So you can see here limin and lim sup is not same. Are you getting this?
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
So if sequence is not convergent, lim sup is not equal to lim in. And if lim sup is equal to lim in, which is equal to limit of a sequence, then it will be automatically convergent sequence and vice versa. If a sequence is convergent, lim sup and lim in must be equal. Is that okay?
Yes,
Yes,
ma'am.
ma'am.
Take third example. Let n is equal to 1 by 2, 2 by 3, 1 by 4, 4 by 5, 1 by 6, 6 by 7. So this is 1 by n, comma, n upon n plus 1. Okay, this is the sequence. So can you tell me now small t1, t2, and what is t1? Infimum of what?
1 by 2.
Whole sequence, right? 2 by 3. And so on, 1 by n upon n plus 1. What is infimum of this? What is infimum of this? It is 1 by 2, 1 by 4, 1 by n. So what is infimum?
0.
0, right?
0.
What is T2? Infimum of 2 by 3, 1 by 4, 4 by 5, and so on. 1 by n upon n plus 1. What is T2 then?
0.
T2 is also 0.
0. Yes, ma'am.
Yes. So what can I say about Tn? Tn must be 0.
Yes, ma'am.
Yes, ma'am. Yes, ma'am. 0.
Tn
Yes,
is
ma'am.
0. What is capital T1, capital T2? It is supremum. Supremum of 1 by 2, 2 by 3, 1 by 4, 4 by 5, 1 by n, and n upon n plus 1. What is supremum? What is supremum of this?
1 by 2.
1 by 2. 1 by 2.
What?
Hmm? 1 by 2 येईल का?
No, ma'am. No.
n upon n plus 1. Supremum काय येईल त्याचं?
1.
1. याचं लिमिट घेतलं ना n upon n plus 1 1 divide numerator and denominator by n and n will get means 1 upon 1 plus 1 by n, so 1 will get na. Are you getting this?
Yes, ma'am.
Yes, ma'am. One. Yes, ma'am. One.
It will be 1.
One.
1.
You can check here with this. आता हे पुढचे टर्म तुम्हाला माहित नाही ना, but I am having nth term and n plus 1th term, so if I take what is limit n tends to infinity n upon n plus 1, what will be this? 1 upon 1 plus 1 by n, limit n tends to infinity. हे कॉर्नरचं दिसतंय का तुम्हाला? नाही. Let me
Yes,
write.
ma'am.
Yes, ma'am.
So limit, if we take limit of this, I will get 1. Is that okay?
Yes, ma'am.
What is T2?
Yes, ma'am. Yes, ma'am.
What is T2? T2 is also 1.
One.
T3 is also 1 and so on. So I will get capital Tn is 1. So what can I say? What is limin?
Zero.
Supremum of small tn. What is supremum of small tn? It is 0. And what is limsup? It is infimum of capital Tn. Infimum of capital Tn is nothing but 1, right?
One.
Are you getting this? So you can see here, this is also not convergent. See, 1 minute. Yes, this is also not a convergent sequence. Is that okay?
Yes, ma'am.
Yes, ma'am.
So we will take a theorem now. We will define or we will state a theorem now. If n converges, then limin of n is equal to limsup of n is equal to limit of n. If it is converges, then limsup limit is equal to limit of that sequence that we want to prove. Okay, so how we will prove this? With examples we have seen, now we have to prove by definition. So let limit n tends to infinity, n is equal to say a, and say alpha is equal to liminf of n and beta is equal to limsup of. For our convenience, we are denoting it by alpha, beta, and a. And what we want to show, what we want to show, what is our claim? We want to show alpha is equal to beta is equal to a. Is that okay?
Yes.
And what is given here? N is convergent sequence. Okay, that much is we have, and we have to show alpha is equal to beta is equal to A. Now, how we will show this? Can you think? We want to show alpha is equal to beta is equal to A. So let start with epsilon greater than 0. Let epsilon greater than 0. Now since n converges to A, limit we are taking as A. N converges to A, what can I say? For this epsilon there exists a natural number k such that what? N minus A is less than epsilon for all n greater than equal to k,
Thank you.
right?
Yes, ma'am.
Yes. Now I can this implies A minus epsilon is less than n less than A plus epsilon for all n greater than equal to k.
Yes, ma'am.
Yes.
Yes, ma'am.
Now since now with the help of this only we have to what is limsup and liminf. Okay, with this only we can find. Now since where is my since A minus epsilon is less than n for all n greater than equal to k, what can I say about A minus epsilon? A minus epsilon is lower bound,
Yes, ma'am.
lower
Yes.
bound of n where n greater than equal to k till, right? Lower bound of a till n greater than equal to k, right? A minus epsilon is a lower bound of tail of a sequence n, right?
Yes, ma'am.
Yes, ma'am.
So
Yes, ma'am.
this implies A minus epsilon is less than or equal to tk, small tk.
Yes, ma'am. Yes, ma'am.
Yes, because what is what is tk? Tk is nothing but
Infimum.
infimum.
Thank you.
So infimum must be greater than or equal to lower bound
Better than low.
of that tail, right?
Yes, ma'am.
Yes.
Yes.
So A minus epsilon must be less than or equal to greatest lower bound of tail, and greatest lower bound is nothing but tk. Am I right?
Yes, ma'am.
Yes, ma'am.
So this implies A minus epsilon is less than or equal to Tn for all n greater than or equal to k. Can I write like this?
Yes, ma'am.
Yes, ma'am.
For all n greater than or equal to k. Now, what is alpha? And alpha is nothing but supremum of Tn. What is alpha? Just now we have alpha is what? Liminf of n. Liminf of n is nothing but supremum of small tn, right? Is that okay?
Yes, ma'am.
So
Yes,
this
ma'am.
implies Tn must be less than or equal to alpha. Alpha is supremum.
Yes, ma'am.
So least upper bound. So Tn must be less than or equal to alpha. Is that right?
Yes, ma'am.
Yes, ma'am.
So therefore, what is the relation between A minus epsilon and alpha? What can I say?
Greater than.
Right? A minus epsilon is less than equal to Tn less than equal to alpha. That is, or this
Yes, ma'am.
implies A minus epsilon is less than equal to alpha. Similarly, for A plus epsilon, we can do the things. From here. Yeah. So from this much part, we have got A minus epsilon is less than equal to alpha. Now from another using another inequality, we can prove what we can prove. What should be the relation between beta and A plus epsilon? Beta must be less than or equal to A plus epsilon, right? But we will prove this. Okay, so we will now consider again from this we can give the number. Also from 1 from 1 we have what we have. N is less than A plus epsilon for all n greater than equal to k. That is A plus epsilon is an upper bound of a tail of ak plus 1 and so on. Is that right?
Yes, ma'am. Yes, ma'am.
So, but what is tk? Capital Tk?
Supreme.
This is upper bound
Least upper.
and this is Tk is supremum. So it is a least upper bound. Tk is least upper bound. So it must be less than or equal to A plus epsilon. Right?
Yes, ma'am. Yes, ma'am.
We can write here. This is nothing but least upper bound. Okay. Since it is least, so Tk must be less than or equal to A plus epsilon. Okay. Now, what can I say about Tn and Tk? This implies Tn is less than or equal to Tk less than equal to A plus epsilon for all n greater than equal to k. Now since what is beta? Beta is my infimum of Tn, capital Tn. So what should be relation between beta and Tn? Beta must be less than equal to Tn
Yes, ma'am. Yes, ma'am.
for all n. Therefore, beta is less than or equal to Tk, which is less than equal to A plus epsilon. So this implies beta is less than equal to A plus epsilon. So where is that alpha? This one. Give number 2 and number 3. This is 3. So what can I say about A minus epsilon? Therefore, A minus epsilon is less than alpha, less than equal to beta, less than equal to A plus epsilon. Alpha and beta, what is the relation between alpha and beta? Alpha must be less than equal to beta only. And we have already proved, you can write here from or using 2 and 3. Using 2 and 3, right? Therefore, we must have A minus epsilon is less than alpha less than equal to beta less than equal to a plus epsilon less than. Is that okay?
Yes, ma'am.
And this is for every epsilon. So what can I say? What can I say about alpha and beta? This is for every epsilon. Mod of alpha minus beta. What can I say mod of alpha minus beta?
Less than epsilon. Less than epsilon.
2 epsilon.
Yes, ma'am.
Yes. And since epsilon is arbitrary, alpha must be equal to beta. Alpha minus beta must be 0. That is, alpha must be equal to beta. Is that right?
Yes, ma'am.
Now I want to show alpha beta is equal to A. How can I say? Now since where alpha and beta belongs to which interval? A minus epsilon and A plus epsilon. So what can I say about A minus alpha? It is less than epsilon.
Yes.
A also belongs to this. Alpha also belongs to this. What is modulus of A minus alpha? It must be less than epsilon.
Yes, ma'am.
Yes, ma'am.
And what about modulus of A minus beta? It must be also less than epsilon. So this must implies
Yes, ma'am.
A is equal to alpha and A is equal to beta. So this gives me alpha is equal to beta is equal to A. That is limsup is equal to liminf is equal to limit. That is liminf of n is equal to limsup of n is equal to limit of n. That only we want to prove. Is that okay?
Okay, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So, okay, tomorrow we'll prove this next theorem, or we can have today only. Okay. One theorem is remaining only in this limsup and limin. We can complete it or
Ma'am,
yes.
you explain the last step
Last.
from that alpha beta belongs to that.
Mhm. Alpha and beta belongs to A minus epsilon and A plus epsilon. So what should be distance between A minus epsilon and A minus alpha and A minus beta? Modulus. Epsilon is my arbitrary. Very epsilon is nothing but very small. You can draw this that इथे A असेल A minus epsilon and A plus epsilon, right? If this distance is epsilon, A minus epsilon and A plus epsilon, 2 epsilon समजा. इथून आणि इथपर्यंतचं डिस्टन्स किती असेल? What is this distance? 2 epsilon ना?
Yes, ma'am.
आणि इथून इतका डिस्टन्स किती येते? What is this distance? What is this distance? It is
Epsilon. Zero.
This is epsilon, right? This distance is epsilon This distance is also epsilon. Now where is alpha and beta? Alpha and beta belongs to this, somewhere in between this. एक तर इथे नाही तर इथे कुठेतरी असेल ते अल्फा अँड बीटा. समजा इथे असेल तर what is the distance between alpha and A? Must be less than epsilon, right?
Yes. Yes, ma'am.
And इथे बीटा आहे समजा. आता समजा म्हणजे इथे कुठेही असू शकतो हा तो ह्या इंटरवल मध्ये. पण ए पासून ते अल्फा आणि बीटाचं अंतर किती असेल? मॅक्झिमम एप्सिलॉनच असेल ना. आर यू गेटिंग?
Yes, ma'am.
Because A is in center. A is in center. Are you getting this?
Yes, ma'am.
A is in center and alpha beta may be within this two epsilon distance, but A is in center, therefore distance between alpha and A must be less than epsilon, and distance between beta and A also must be less than epsilon. And here we have written distance between alpha and beta is 2 epsilon because we don't know. It may be here, it may be here, somewhere here. But it cannot exceed 2 epsilon, right?
Yes, ma'am.
And epsilon is arbitrary, so A must be equal to alpha is equal to beta and so on. Is that okay?
Yes, ma'am.
Now next theorem. If n is bounded and liminf of n is equal to limsup of n, then n converges. Sequence n converges and they must be equal. Limin or limit of n is equal to liminf of n is equal to limsup of n. Is that okay? So in first part it need not be bounded. But for second part, means if we assume it is bounded, then it is vice and versa. Like converse is also true. What is happening? Yes. Is it okay, this statement? So quickly we will do this. Again on same lines proof. Let A is equal to liminf of n is equal to limsup of n. Okay, so limsup and limin we have given to be equal and we are denoting as say A, and we have to show it is nothing but a limit of that sequence. That sequence converges, n converges, and that is nothing but its limit that we want to show. Now since n is bounded, A must belongs to R. Bounded sequence of real number, so its limit must belongs to, limit is also, or we, okay, limit is real number only and A belongs to R. Now we want to show convergence. So for convergence, how we start? Let epsilon greater than 0. For this epsilon greater than 0, if we can prove n minus a modulus of n minus, if there exists some natural number such that modulus of n minus a is less than epsilon for all n greater than equal to that natural number, then we can say n converges, right?
Yes, ma'am.
Yeah, so start with epsilon greater than 0. Now since A is equal to supremum of Tn, why it is supremum of Tn? Because this, are you getting this? This is nothing but Tn, small tn. This is nothing but capital Tn, right? Liminf of an is nothing but a. So since a is equal to supremum of Tn, small tn, what can I write? A minus epsilon is not an upper bound. Since a is equal to supremum of Tn, a minus epsilon is not an upper bound for Tn. So what can I say? Therefore, there exists k, instead of k, I will write k1 belongs to natural number such that a minus epsilon is strictly less than tk1. Understand this step? Is that okay?
Yes.
Because it is not an upper bound. A minus epsilon is not an upper bound, means there exists some term of that sequence which is greater than a minus epsilon, right? So a minus epsilon is, say it is tk1. Is that okay? And this implies a minus epsilon is less than tk1, which is less than equal to n for all n greater than equal to k1. Is that okay?
Yes, ma'am.
So this implies a minus epsilon is less than n for all n greater than equal to k1. Similarly, also, what is a? A is nothing but supremum of, sorry, infimum of Tn. Also, infimum of capital Tn, right?
Yes, ma'am.
Also, a is equal to infimum of capital Tn, or we can write limsup of an and then infimum. Limsup of n, which is nothing but infimum of capital Tn. So what can I say about a plus epsilon? A plus epsilon is not a lower bound, right,
Yes, ma'am.
of capital Tn. Therefore, there exists at least one term of that sequence. So there exists a natural number k2 belongs to n such that tk2 is strictly less than a plus epsilon. Because a plus epsilon is not lower bound, manje there exists some term which is lesser than that a plus epsilon, right?
Yes.
So this implies an is less than equal to tk2, which is less than a plus epsilon for all n greater than equal to k2, right? Therefore, an is strictly less than a plus epsilon for all n greater than equal to k2. Is that right?
Yes, ma'am.
So I am having a minus epsilon less than this for all n greater than equal to k1, and n is less than a plus epsilon for all n greater than equal to k2. So take maximum of k1 and k2. What can I say then? We are having two natural numbers after that stage. So take k is equal to maximum of k1 comma k2. Then what can I say? A minus epsilon is less than n less than a plus epsilon for all n greater than equal to that k. Can I write?
Yes, ma'am.
Yes, ma'am.
Yes. So what this implies? What is this? Modulus of n minus a is less than epsilon for all n greater than equal to k. So what this implies? That is nothing but n converges to a, and that is nothing but, therefore limit of n is nothing but a, and which is nothing but liminf of n, which is nothing but limsup of n. Is that right?
Yes, ma'am.
This completes the proof.
Yes.
Yes.
Okay. Any doubt?
No, ma'am.
No, ma'am.